Hello students, today I am going to cover the topic on knowledge representation techniques. In the last lecture, I actually told you about how artificial intelligence objective is to design an expert system, and any expert system requires a huge amount of knowledge. So it is very important to know how to represent that knowledge. So in today's lecture, I'll tell you about the knowledge representation techniques. But before that, I'll tell you about what actually the expert system is. So the definition of expert system is expert systems are artificially intelligent programs that achieve expert level competence in problem solving by acquiring knowledge about specific tasks. From this definition, it is clear that expert systems are basically designed for a specific task. And for this specific task, any intelligent program has to acquire the knowledge, or any intelligent program has that capability to acquire that knowledge for that specific task so that it can compete in the problem solving process. The structure of an expert system reflects the understanding of the methods of representing knowledge. So this structure of expert system basically tells how to perform intelligent making tasks with the support of computer-based systems. So in that way, expert systems are organized in three distinct levels. The first level is knowledge base, the second is working memory, and the third is inference engine. This knowledge base basically consists of problem solving rules and procedures which are relevant to any problem domain, and it has been handled by those knowledge engineers. So usually in the knowledge base, the stored in the form of if-then rules. The second level, which is working memory basically provides task-specific data for the problem under consideration. That means working memory provides relevant data for current problem being solved. So this working memory is the dynamic module of the system. The task-specific set of rules generally stored in the rule base. So there is a workspace in this working memory. That workspace has a rule base, and that rule base actually consisting of the set of rules. Now, the third component of expert system is inference engine. Inference engine basically is a control mechanism that applies axiomatic knowledge in the knowledge base to the task specific so that it may arrive to some conclusions or solution. So basically जो ये inference engine है, that uses the process of chaining through rules either in a forward direction or in a backward direction until the conclusion is reached. So inference engine is actually a knowledge reasoning, is actually about the knowledge reasoning. So it It applies those axiomatic knowledge through which we can arrive or we can get something or from that given knowledge. So this is all about the expert system. Now the main topic for today's lecture was the techniques of knowledge representation, and there are four techniques. The first, logical representation, semantic networks, production rules, and frame representation. In the problem solution through searching, we have already used those production rules, and we have created these production rules for some common games like missionaries and cannibals, water jug problem, and so on. So we will start from these techniques. The first technique, that is logical representation. So logical representation is a language with some concrete rules that deals with the propositions and has no ambiguity in the representation. So logical representation basically forms a set of rules that deals with the prepositions. Prepositions is basically the sentences that has no ambiguity in the representation. So knowledge representation means drawing a conclusion based on various conditions. Means we do have a set of knowledge, and on the basis of that set of knowledge, we can be able to deduce more set of knowledge. And the knowledge representation consists of the precisely defined syntax and semantics, which supports the sound inference. So this kind of inferencing or deducing would be done on the basis of these two terms, syntax and semantics. So each sentences can be translated in knowledge logical representation into logics by using the syntax and the semantics. Here, syntax are those set of rules which decide how we can construct legal sentences, determines which symbol we can use for knowledge representation, and how to write those symbols. So syntax is basically the grammar of any language. So here if logical representation is a language, so obviously syntax would represent the grammar of that language. And semantics are the rules by which we can interpret the sentence in the logic. That means we can interpret the meaning of the sentence in the logic. So semantic also involves assigning a meaning to each sentence. So there are two types of logics we will cover in this logical representation. The first one is prepositional logic, or we can say prepositional calculus. The second is predicate logic, which is also called first order logic. And the terminologies used for this, for prepositional logic, we call it PL, and for predicate logic, we called it as FOL, that is first order logic. And in the last, we will discuss about the advantages of logical representation. Logical representation basically enables the logical reasoning. And if we talk about the logical, that means it is based on some factual knowledge. And the second advantage is logical representation is the basis of any programming languages. So for any traditional languages, we should know before executing any program, we should know the logic of the problem. The disadvantages of logical representation, that is the restrictions, and are challenging to work with it. Because if I am representing all the real world into through a machine, then obviously I will face various restrictions, and how to work with those restrictions would be a challenging task for any logical representation. The second disadvantage is logical representation technique may not be very natural, and inference may not be very efficient. So basically, in logical representation, we do have a set of knowledge, and on that knowledge we applied some inference rules, and we deduct or conclude some more knowledge about it. So it is not necessary the knowledge we have concluded from the given knowledge would be that much efficient or would be that much natural. So I'm ending over here. I'll come up with my next video with the topic prepositional logic, and next later on we will discuss about the first order logic. Thank you students. Keep watching and listening.